Hello everyone. I welcome you all to this session on statistics. Fourth semester BCom RCUB statistics syllabus. You have 5 units. Under that, the first unit starts with binomial distribution. So here we are going to study about binomial distribution and Poisson distribution. So first let us see. In this session we are going to look into only binomial distribution. So let us see what is binomial distribution. So binomial distribution was given by Swiss mathematician James Bernoulli in 1700 and was first published in 1730. It is also known as Bernoulli distribution as it is given by the Swiss mathematician James Bernoulli. It's also called as Bernoulli's distribution. So actually in case of binomial distribution, the term bi means two. So this statistical tool is applicable to uh, a trial where you will have two outcomes. So only two outcomes. For example, if you toss a coin, you can either get a head or a tail. You cannot get both at a time. So it is exclusive. Either you have to get head or tail. Only two possible outcomes. In the same way, if you consider any events or any experiments wherein there is a possibility of getting only two outcomes, it can be either success or failure, pass or fail. Such a probability distribution which gives two possible outcomes for which we are going to apply this binomial distribution. So here, okay. For example, if a new drug is introduced to cure a disease, it either cures the disease or it doesn't cure the disease. So, if you are introducing a drug or medicine for a disease, either the patient will survive or he'll die. It cannot be half dead and half survived. So, either it should be successful or it should be failure. So, if you purchase a lottery ticket, you are either going to win the money or you are going to lose. So, in which of the events or experiments where you are going to have only two outcomes, it may be pass or fail, it may be success or failure, it may be win or lose. To such events, we are going to apply this binomial distribution. Okay. So, the formula for binomial distribution is probability of x given by n9p is equal to NCX. So for NCX, below you can see here, this is the what we say, the elaborated version of NCX. Okay, so that is n factorial divided by x factorial into n minus x factorial. P of x, p to the power x, here it is p to the power x into 1 minus p to the power n minus x. 1 minus p is equal to q because p plus q should be equal to 1. Okay. So, if in the problem p is given, you can find out q by deducting that p value from 1. So, here in the formula, binomial probability, x total number of successes, p probability of success on an individual trial, n number of trials. Okay, this is the formula. So, actual formula is NCX into p to the power x into q to the power n minus x. So, how to find NCX? That is n factorial divided by n minus x factorial into x factorial. Okay. Then properties of binomial distribution. The main parameters of binomial distribution is N9P. So N9P is very much required for the calculation. Range of binomial distribution is x is equal to, it starts from 0 till n. For binomial distribution, the probability mass function is ncx into p to the power x into q to the power n minus x. For a binomial distribution mean, how to find out mean for a binomial distribution? NP, that is n into p. Variance will be equal to n into p into q, npq. Standard deviation will be the square root of variance. Okay. So binomial distribution tends to Poisson distribution when n is infinite and p is 0 and np is equal to lambda, a constant. That is, when n is very large and p is very small, cannot apply binomial distribution and it tends to Poisson distribution. Binomial distribution tends to normal distribution when n is very large and p and q are almost the same. Okay. Then we'll see, in a binomial distribution, if n is equal to 6, p is equal to 1 by 3, find the mean, variance and standard deviation. So mean in case of binomial distribution is n into p. So you know n here, n is 6 and p is 1 by 3. 6 into 1 by 3, 3 ones are 3 twos are 6, 2 into 1 2. Variance n into p into q. So you will get the value 1.33. So here you know n is 6, p is 1 by 3. What about q? So if p is given, you have to find out q by deducting the p value from 1. p plus q, p ಮತ್ತು q ಎರಡನ್ನ ಸೇರಿಸಿದಾಗ ಅದು ಒಂದಕ್ಕೆ ಸಮ ಆಗಿರುತ್ತೆ. ಸೊ p ಯ ವ್ಯಾಲ್ಯೂ ಕೊಟ್ಟಿದ್ರೆ ನೀವು q ವ್ಯಾಲ್ಯೂವನ್ನು ಕಂಡುಹಿಡಿಬೇಕು. ಹೇಗೆ? 1ರಿಂದ p ವ್ಯಾಲ್ಯೂವನ್ನು ಮೈನಸ್ ಮಾಡಿದರೆ q ವ್ಯಾಲ್ಯೂ ಸಿಗುತ್ತೆ. ಅಥವಾ q ವ್ಯಾಲ್ಯೂ ಕೊಟ್ಟಿದ್ರೆ p ವ್ಯಾಲ್ಯೂವನ್ನು ಹೇಗೆ ಕಂಡುಹಿಡಿಬೇಕು? 1 ಮೈನಸ್ q ವ್ಯಾಲ್ಯೂ. ಸೊ p is equal to 1 by 3, then q will be equal to 1 minus 1 by 3, that is 2 by 3. So n into p into q, you got 1.33. Standard deviation is equal to root of the variance. So if you take the square root of the variance, you will get 1.1547. Second question, if a binomial distribution has mean 3 and variance 2, find the parameters. The parameters is n and p. So np is 3, npq, variance is npq is equal to 2. So q is equal to, how to find q in binomial distribution is q is equal to npq divided by np. So npq is 2 and np is 3. If q is equal to 2 by 3, then p is equal to 1 by 3. Now substituting the values, n into 1 by 3, np is equal to 3. Okay, n into, n value we do not know, p we know, 1 by 3. So np together we know it is 3. So then n into 1 by 3, 3 into 3, 9. So when you bring 3 to the right side of the equal to sign, so the division becomes multiplication. 3 into 3 is equal to 9. So n is equal to 9. So the third question is, 40% of the buttons manufactured by a firm are found to be defective. In a random sample of 6 buttons, find the probability of getting exactly 4 defective buttons. Okay. So here 40% is the p value, that is 0.4. So if p is 0.4, q is equal to 1 minus 0.4. So if 40% is defective, 60% will be proper. So q is equal to 60% or 0.6. Okay. So n is sample, that is 6. So now we have to find out of the 6 buttons, what is the possibility that exactly 4 buttons will be defective. So the formula is probability of x. X value here is 4. N is 6. Okay. P is 0.4. Q is 0.6. So P of x, that is P of 4, is equal to 6C4. So 6C4 means 6 factorial. divided by 4 factorial into 6 minus 4 factorial. So you will get the value 15. For this 6C4 you will get 15 into 0.4 to the power 4 into 0.6 to the power 6 minus 4. So the final value, that is, out of these 6 buttons, what you take the sample. 6 ಬಟನ್ಸನ್ನು ಸ್ಯಾಂಪಲ್ ಆಗಿ ತೊಗೊಂಡ್ರೆ ಅದರಲ್ಲಿ 4 ಬಟನ್ಸ್ ಸರಿಯಾಗಿರೋಲ್ಲ ಅನ್ನೋದರ ಪರ್ಸೆಂಟೇಜ್ ಎಷ್ಟಿರುತ್ತೆ, ಚಾನ್ಸಸ್ ಎಷ್ಟಿರುತ್ತೆ ಅಂದರೆ 0.13824. ಸೊ ಅಪ್ರಾಕ್ಸಿಮೇಟ್ಲಿ 14%. Okay. This is all about a brief introduction to binomial distribution. We'll see in the next session. We'll continue.